All right. Hello. So I just met with the other instructors for this course, and we kind of came to a conclusion. We thought that it would be best, instead of holding a fourth session, that we can just record it and send it out. I know this is a busy week for many people with exams, and we have very, very little to talk about. There really is no need to hold a 2 hour session. This video is probably going to be 10, 15 minutes long, just telling you a little bit about the final project. And what we're going to do is just really utilize our Slack. If you guys have questions on any of the things we talk about today or your final project, obviously you can shoot us a message. We can probably set up some time to do one-on-one conferences if needed to talk about the project. And then for the fifth week, we'll resume back for a last in-person session. But this one, we're going to try something new. We're going to see how this would go if we just did it virtually. Like I said, there's so little to talk about. So we're going to go ahead and just cover the few things I'm going to talk about for this fourth week. So the first thing is obviously, right, your final project. This is 90 out of the, I think, 310 points in the class. So this is a good 30-40% of the grade. This is what everybody really loves about the class. This is what we enjoy the most, seeing all the creativity and everything that's going to come out of what you guys have been learning. So the instructions are very straightforward because we don't want to hinder your creativity. You have to make a CAD model from scratch. It cannot be anything that we've covered so far in the class. So it can't be an engineering fountain, no plane, no Lego cars, right? It's everything that we've done. Something original. And it needs to contain more than 5 design features, which honestly is very, very little. We should probably make it more like 20, 30 to actually stretch it out. But again, this final project really is a culmination of everything that you've learned. So what you're going to be getting out of this class, like we told you at the beginning, is what you're willing to put in. So there are some final projects that are always super, super, super good and impressive, and there are others that are just there to get by. Again, we can't really enforce anything, so this is so much for you. We're going to print these final projects, and we're going to give you a copy of them to put on your desk or whatever you want. If you want to make something functional, that's cool too. So the motivation is actually getting this project done for yourself. So as much effort as you want to put into it, that's what we're going to leave it at. Here are some general ideas, some things that we've told people before in the past. Anything Purdue related, right? We always get a bunch of Boilermaker specials. We get a lot of clock towers. You can do that if you want to make some mechanical units. So we've had people who have made like engines and gears before, like working gear boxes, I guess. Anything related to your major. I think one person our last session made the hammer from the ME263 project. Anything related to your home, anything that is your hobby. So again, there really is no restriction. Anything that you want to make, right, we're going to print it for you. We're going to help you design and get it all done. And just here's some generic ideas, right? So we start off with the CAD model. This is a good 90 points. You're going to have about 1 to 2 weeks to get this done. Make any CAD model from scratch. Actually, at this time, I'll show you some examples just in case you want to see some more. Here are some cool ones that we've had before in the past. Just some quick ones I grabbed. So we got this one. Here's another one. And then we got this one. All right, and you can see they all probably took different amounts of time. Again, it's what you want. We can't really enforce you to put a lot of time into it, but that's just kind of the area of where people put their effort into this project. So once you make your project, we're going to go ahead and we're going to render it. So what rendering does is it's a tab completely separate from CAD in Fusion, and it allows you to get a more professional look for your CAD model, right? So if you're going to go to a professional presentation, I'll put this back up. I think these are 2 different models, but you can tell, right? If you had this image on your PowerPoint versus if you had this image on your PowerPoint, right? The one on the right looks a lot better. It's a lot more polished. The resolution's a lot better. You don't have all those ugly sketch lines and grids. So the reason we do rendering and the reason we teach it is, it sucks to put all this effort into CAD and then you go to take a screenshot of it and it looks pretty poor. So this really helps you kind of polish and make all your hard work really taken accounted for. So this is a quick 10-point assignment. It's really low, but the reason it's low is because you can't do it without making your project. So that's why the project is worth that full 90 points. So what you're going to do after you've made your model is you're going to apply appearances to it. So this is, we've done this before in the past, where you're going to right click appearances. you'll add textures and colors to it, and then you'll open up the render tab. You'll import some background. So we want it to look just like this image on the right, right? There's a background. The model itself actually has an appearance to it, and then we're going to go ahead and render it. So I'll show you really quickly over here what I mean by that. So I will go and find a random part that we've made so far. So I'll take this bridge, for example. Right, so this bridge is done. It has its appearances added to it, right? Right click, appearance. You can tell we have this paint color to it. You can go a little bit more in depth to it. I hope you guys do. Again, this is a really great example, but you can tell just how many appearances are on here. You have this bronze color, and then there's yellows and whites all over it. This is a pretty poor example, but it's just to show you exactly what we're doing. So up here on the left, where it says design, we're going to change our workspace for Fusion. So we're going to get out of the designing phase, and we're going to get into that graphic design phase, which is rendering. So we're going to click out of design, and we're going to go into render, which is this option right here. So once we're there, again, you'll see your whole screen has changed, and now we're in our rendering option, right? So everything that we have from this tab now carries over to render. So if you ever want to go back and make any edits, again, go back to design, change your color, change your part, and then go back to render whenever you're done. Your taskbar up top is very, very plain. There's really not too much to this part of the project or rendering in general, right? It's not CAD, it's more like graphic design. So just to show you what these buttons up here do, over here is appearance. So this is a quick way to change your appearance again. This next one is kind of the big one. This is scene settings. So whenever we spoke earlier about one of the requirements being having a background, this right here is how you add your background, right? So you can add your appearance from here, and the next option is to get your background. So we want to change the background into environment. So you change it to environment, and then you can tab over to the environment library. And now you see you have all these options of backgrounds to apply to your image. So we'll select a field, for example. There you go. And it's the same controls as Fusion, so I'm using Shift middle mouse button, and I can begin to kind of pan around. And we're just trying to create a good image. It's pretty much like a screenshot, so we're going to kind of move around, pinch, pull, move things around. We can mess with all the settings, and then whatever we have on our screen is what the screenshot is going to be. So again, you can always change your background if you're not happy with it. There we go. And again, just keep moving it around until you get what you like, right? This is just a picture, so make the picture nice. And what I'll mention is you'll probably notice the background is pretty bad looking, right? It's very low resolution. And that's because these backgrounds are of very, very, very high quality. Within Fusion, there's only a few of them. I wish they had more. But the cool thing is there are some open libraries, such as this one. I'll send them all in the Slack, but there's some pretty cool libraries. So if you want to go and add more options to what you're given, right? So, you know, you'll have, like, here's a gym. Here's some really good backgrounds for the sky. But what you'll notice about all of them is whenever you pull them in, right, the background looks very, very bad. And that's as to, so it doesn't crash your computer, right? They're very dense images. They're 4K plus. So to kind of start the rendering process, right? So we applied an appearance, we applied a background. We first want to do a rough draft, and then we're going to do a final draft. So the rough draft button is this one right up here with the plus button, and you'll push it, and it'll slowly start to render the background. It'll do about 90% of the final draft. So as you can see, right, it's slowly getting better and better quality. Whenever we go to do our final render, again, this is what it's going to look like. If you're not happy with it, again, it is a rough draft, so you can move it around. It's going to break it, but then as soon as you let go, it'll start rendering again. All right, so again, there's nothing concrete about this part of the final project. This is for you to play with and to really kind of showcase your design. Again, make your design nice, give some good appearances, get some good scene settings. If you really want to like tell a story, there's lots of good backgrounds on this page and the other ones I'll be sending out. So you can really try to customize it and make it your own. Whenever we're done, right, you're fully happy with what you see on your screen. This button all the way on the right, the teapot, is to get that final draft done. So you'll click on it. And then these are all just generic photo settings. You don't have to tweak with them if you don't want. I think I always have mine set to these. If you want to go ahead and copy them. The thing that I just want to point out is make sure you have it with cloud render. So what's going to go on is you'll notice these things called cloud credits. So whenever we push render, it's going to send this over to Fusion's cloud, and it's going to render it for us. And it costs money, right? These credits cost money. Big companies have to pay for them. But as a student account, right, you're pretty much given unlimited amount of them. So this is kind of the currency to make sure that you don't abuse the system. And as you can see, it's going to take 1 credit. And we want it to be a cloud render, right? Cloud render, final, and here's the credit cost. So whenever we push render, it's going to send this file away to their servers, and it's going to render it in the background. And whenever it's done, it'll send it back to us. So you'll notice this is your image right here. Make sure you remember the time it tells you. So I think it told me about 20 minutes. So now that we push render, right, it took our token, sent it out to Fusion. You can turn your computer off, you can close out of Fusion, you can stay here. But after those 20 minutes have passed, if you come back to this exact spot, right here is going to be your image. So you can just click on it, and then there should be an option somewhere along the top bar to save to PDF, save to JPEG, and then that way you can export it out. Really quickly, let me just show you some other examples of what these renders look like, right? So this was that arc reactor from earlier. I think this one looks really well with how all the colors contrast with the bright white and then all the dark tones on the inside. And here's another really good one. This person went out and got a custom background. So again, you can tell it's really, really bad looking. But whenever you do the rough draft, right, it's going to really sharpen it, and then you can begin to see what this final quality image looks like. So again, here's just 2 examples of what this part of the project looks like. It's not super crucial. Again, if you just want to do just enough to pass the steps, that's totally fine. But this whole final project is for you, so put in as much into it as you would like to. Okay. All right, so that's this part, right? So rendering is very simple, very straightforward, pretty separate from all the CADing that we're doing in Fusion. Follows a little bit more of graphic design. Everything that I showed you is everything that you need to know. And again, as everything in this class, play around with it, and you'll begin to learn a lot more about what the things do. But that's kind of the essentials. So next, and the final part of this class, right, is going to be 3D printing. So this final 5th session that we're going to have is going to be on 3D printing. I know this course is called CAD/3D printing, but what I always tell people is 3D printing has been advanced very, very, very rapidly, and to use and operate a 3D printer does not take that much intelligence. It works pretty similar to like a toaster or an oven. There's a few buttons to push, and the whole thing of the technology is that it does it all for you. So you don't really need to understand too much, but more so just how to set up the machine and what options to put to get it to run for you. So the type of printing that we're going to be using is called FDM, or Fused Deposit Modeling. And this type of technology falls under additive manufacturing, right? So this is the specific type of printing we're doing. 3D printing in general is known as additive manufacturing. And this is the process of creating an object by just making it in individual layers. I'll explain that more whenever we get to that part of the assignment. I'll actually show you how to get them 3D printed, and I'll show you what we mean by layers. But how 3D printers work is, if you kind of look in this image with this little red line, that is our filament. And so 3D printers heat up this filament to super, super, super hot temperatures, and it will lay down a single layer, just as you see right here. So the filament gets to the end of the nozzle like a pen. It's heated up to super, super, super hot temperatures, and then it's just laid out in millimeter thick layers. So you do layer 1, and as soon as you're filled, you move up to layer 2, and then you lay down layer 2. And some of these prints are gonna have, 100 to maybe 600 different layers. So that's why some prints can take, 10, 12, maybe even a day. Depending on how tall you make it, there's gonna have to be multiple layers, because if it's like 6 inches tall and each layer is 0.1 millimeters thick, right? You can do the math. You'll figure out how many layers it is. That's a lot of time the printer has to spend making it. And yeah, like I said, this technology is adapting so quickly. It's being used all over the place in all the industries, aerospace, automotive. It's now being used to print houses. I'm not too sure if any of you have ever seen those videos, but like this one down here, it's starting to be integrated with biology. So you're being able to now print human parts and muscle mass and stuff like that. And then you can use it to print other things such as food, clothing, jewelry, art. It's a really cool thing to know because of how the future is being paved. So this is definitely a really cool tool for you guys to all know. As I said earlier with FDM, right? This is one technology. This is the one that we're using. There are several other ways to 3D print. So there is SLS. So whereas FDM uses plastic, this uses powder and lasers to melt and make your parts. And then there's stereolithography, which instead of powder or plastic uses resin and light. So if any of you ever had braces and the orthodontist shined that light in your mouth to harden the glue, it's pretty much what this does. Is you'll have lights that will shine at correct places to harden the resin to make your parts. FDM is very widely known because it's very cheap, it's very universal. These two are very expensive. You're not really ever going to find somebody who has these for personal use. This is probably going to be found more so at a company or a college like here at Purdue. Very expensive machines. And then FDM, as we've been talking about, like I said, it's the most widely known one. So we talked about a little bit about how 3D printing works. So this fifth session is going to go really in depth into it. That's a quick Spark Notes just to get you started. But what we're going to do with that knowledge is we're going to slice our files. So whenever you're done with your part, right? So again, I'll use this one as an example. So we spent a couple hours, we made our final project, we're happy with it. We need to export this file to a slicer because we need to create code for the 3D printer to be able to print this. And we're not going to do it by hand. We're going to use something called a slicer, which is the middleman. So all of this that we see on Fusion has some sort of code that tells Fusion what it is. 3D printers have that same code, but you can look at it in two different languages, right? Like English to Spanish, Spanish to French. So we're going to use something called a slicer that's going to convert all of this into a compatible form that the 3D printer can use, read, and copy and make. So with your part done, you're going to go over to File, you're going to go to Export, and then you're going to change this file extension to .stl. And this is the universal file extension for 3D printing. So you would push Export, and you would get it done and put on your computer. So for this case, this assignment, we're going to use something called a Benchy. So you're going to open up Ultimate Akira. We'll send out the download instructions. But whenever you get open to here, it's going to ask you what printer you want. The one that we're using is the Creality Ender 3. It's not too crucial. It's just, it'll change some of the settings a little bit. So if it doesn't ask you what printer to use, don't freak out. If you accidentally select the wrong one, don't freak out. If you just want to be with the rest of us, again, this is the printer that we use. So it'll change the specs a little bit. It'll change like the size of the bed, and then it'll change a few of the settings, but it's nothing crucial. So to get a part in here, we're going to go to File and Open Files. So for this assignment, right, we're going to handle the printing of your project, but we still want to show you how to slice parts. So we're going to slice this thing called a Benchy, and this was designed by someone to be a torture test for 3D printers. This part is notoriously very hard to print, and whenever you buy a new printer, it's typically a good manner to go ahead and print this and just kind of see where your printer is at. If it does it successfully, that means you have a good one. If it fails, maybe there's a problem with it, or you should have gone out a little more and bought a more expensive one. So this is a universal test to see how your printer works. So we File, Open File, we brought this file in, Now we need to get it laid out into the middle of the bed, right? So this is what the printer sees. This is its bed. The dark gray outline is like the max boundary, and then the white in the middle is where you're actually allowed to print. So we can select our part, and over here on the left is all the tools that we'll need to set up this print. So you'll notice this first option is going to be move. So we can go ahead and move it to the center. And we know our part's good once we get this yellow color. Another good way to get it to put it in the best place, right? So if you have multiple parts, you'll have to slide them around, but there is kind of like an auto generate feature. So if you go right click, arrange all models, it'll put it in the center. It'll make everything squared off. So that's kind of a way to cheat, but hey. So we can move it to the center, and then this next tab is going to be scaling. So you'll notice by default, uniform scaling is going to be on. So if you go in and change any of these buttons, so if you can put this at 50, it'll scale it up. You can put this to 40, and it'll scale it up. And I'll put it back to default. All right. So if you design something small in Fusion, right? So let's say you go ahead, you design a part in Fusion, you can pull it into here, and this is actual real life. So this is what the printer is going to see and do. If you realize your part's too big or too small, you can quickly tweak it here instead of having to go in and redesign it all. Right here, the options to scale. And again, if you have uniform scaling on, you can tweak any of these numbers, and whatever percent increase that is, it'll do it to the other two as well. Additionally, this last option is just in case you want to rotate any of your features. But again, really the most important ones are these two right here. So for this assignment, all we're asking for you to do is to change this to 120 and then go over here to settings. You'll notice there's very, very, very few settings. Actually, these are the ones that you'll have to do for the final project. So set this to dynamic quality, this to 20, and supports on. So this is kind of the simplified, dumbed down settings. If you open up custom, you'll notice there are a lot more settings. Each of these opens up to have way more. And again, we'll cover this more in the printing session, which is the last one. But the truth is that most of these settings are irrelevant. The cool thing about using these slicers is that they are partnered with these companies. So if you go ahead and import the right printer, all these settings are going to be changed to the manufacturer. So you could go in and mess with settings such as travel, speed. You could go in and mess with the cooling right here. But whenever you set this to a printer, right, everything's automatically set to the optimized setting per the manufacturer. So if you want to override them, go for it. But, for the basic, novice, maybe even intermediate, these really never have to be messed with. It's these ones right here that we will talk about more later. But if you're going to mess with anything, it's going to be these right here. So you put these settings on. Oops. You scale it properly to 120. So I'll do it. And then we're going to go ahead and push slice. What we're looking for is about a 23-hour print. So if you get that correct, that means you did the assignment correctly. And this will just take a second. Again, it is a 23-hour print, so you can kind of figure there is a lot of computing power that it has to do to get this part chucked out. Okay. In the meantime, because that may take a second or two, I'll talk about just one or two pieces of advice. These slides right here are just a summary of what I just said. But this last session is going to be a printing session, right? We're going to sit you down. We'll show you how to run a 3D printer. Again, they're super straightforward and very simple. But for designing your projects, something we want to talk about is the support tool. So with 3D printers, right, you're going to have multiple layers. And I think this is a better example. So you can take a look at the V all the way on the left. When the printer starts the code, it's going to lay down layer 1. And then once it's done, it'll move up to layer 2. It'll lay down layer 2. And eventually it's going to get to this part right here where it splits off and it's no longer going vertical, right? It's going off to the sides. So when you need supports let me go back to this image. You can read this line right here, right? So eventually you're going to get to some parts of your print where you need to fight the effects of gravity. So right here with the V, every layer has the previous layer to be built upon, right? Layer 67 can be built off of layer 66 because that material is there. But if you take a look at the H and the T, when you get to this layer right here and this layer right here, right, there's no material. You're printing in midair, and just due to the effects of gravity, all that's gonna fall, and you're gonna end up with a big mess. Let me see if I have an image pulled up for it. It'll get something like this, right? This is an example of a failed print. So you generally want to avoid having big overhangs. So like in this case, this image is trying to showcase this long straight part is an overhang. So what we do with supports is we add additional material that's typically a lot lighter, simply just to give a platform to print some of these what would have been impossible layers. So you can take a look at this image and this one. I feel like this is kind of a difficult thing to explain. It's a little bit more so of common sense, but again, just take a look at these parts that are sticking out. Again, the bridge of the H, the bridge of the T. This image, again, I think does a really good job. Printers are limited just by gravity force. So if you have big overhangs, like 45 to 90, your prints probably aren't going to turn out the best. But if they're anything from 0 to 45, they'll print fine. The reason I'm briefly mentioning this is just to take this into consideration when you're designing your parts. So you would not want to design something like a bridge for us to print, because that is pretty much the epitome of what an overhang is, right? You don't want to make big, long vertical platforms because they don't print properly. That's kind of the summary of this quick little thing I'm trying to explain. I'll pull this back up because it finished. You'll notice 23 hours. I'll go to preview and I'll show you what we see here with the supports. So everything in light blue is going to be supports. So everything that kind of sits above the light blue, if I can pan, here we go. So for example, the top of this boat and the sides of the boat, right? This was intentionally designed poorly so that we could test the printer. But you'll notice all this light blue is gonna have to be added because this was designed poorly and can't be regularly created by a printer. So you have to add on additional material to kind of suffice and make these prints possible. So it's not crucial, not end of the world, but just take that lightly into consideration whenever you go to design your final project. Don't make things that would be impossible to print, again, by just having super long overhangs, as you saw earlier. And then really quickly, just to show you what we see here. So right here is our print time. We have 22 hours and 41 minutes. Down here is the grams you use the filaments. This is 108 grams. And then right here is our layer counts. As we said earlier, whenever we print, we do layer at a time. So this is our first layer. And then eventually we slowly build up layer by layer all the way up to layer 692, which is the final layer. Okay, so that is pretty much the summary of this last assignment, which is the slicing the benchy. So you'll be turning that in. You'll be turning in your PDF or JPEG of your render, so something along the lines of this. You'll also be submitting your STL, right? So we can print your project for you. And again, that's just right here, file, export, STL. And then you'll just be submitting, actually, yeah, that's it, those three. So the render image, your STL, so we can check your part, and then that screenshot of the slicer. Same thing that we've been doing as before, take a screenshot of the whole screen. And that is all we have left for this course. Again, we'll do a quick demo on 3D printing on our last week, but you guys will have 2 weeks to put this project together. As I said, this is kind of the pinnacle of our course. We can't force you to work harder than you don't want to. So if you really want to make something really, really cool, we've had absolutely amazing projects. Some of the really, really nice ones we end up making a little bit larger. for the people to kind of take away as a trophy. But again, we'll make these all for you. So you can make something practical if you'd like. You can make something just cool to sit on your desk. I think I have the engineering arc right behind my computer right now. Try to make it small. I'll send this out in a note instead. But that is all we have for the rest of this course. So thank you guys.